Right, today I'm going to review these LED bulbs from Osram, also known as Sylvania in the US, from their LED driving range. Now these are, this is a festoon bulb. The size is 41 millimeters, although that size is usually not exactly critical when you're replacing a filament bulb because the prongs that are used to hold these festoon bulbs are usually quite flexible, and assuming there's enough space in the enclosure, then you can usually get away with a sort of plus or minus, let's say, 5 millimeters of difference. So don't get too hung up on that. If you have, say, like a 38 millimeter fitting, then this bulb's going to fit fine. It's intended to replace these. Obviously, this is the original filament bulb that I'll be replacing. Now this is a 10 watt filament. I'll talk more about the power and brightness in a second. I'll just go over some of the characteristics that are advertised on the package first. So this is a warm white bulb, and they don't say actually on the package here, which would be unfortunate if you were looking at this on a shelf in a shop. But they claim it's a 4000 Kelvin white color, which is not very much of a warm white. It's much more of what I would call a neutral or pure white. That's fine. That's why I bought it. I want that color. But if you're looking for a genuine warm white that duplicates the color of these, then this is not going to be the same. So you need to understand that. They're also available in a cool or cold white, which is to say something around 6000 Kelvin, which will look relatively blue compared to this. I didn't want that because I'm going to be using this as an interior light in my car, and I don't want it to look too harsh or cold. What else do they say here? Brightness, 3 brightnesses. I don't know what that's supposed to mean. 41 millimeters, and then they claim 360 degrees of light around the light bulb, which is pertinent depending on the enclosure that you're going to be putting it in. For example, here is the Philips equivalent to this Osram or Sylvania bulb, and this festoon bulb they only have this. You can see the yellow chip there. That's the LED. That's only on the one side of this bulb. On the back of it, there's nothing. So this only projects light, essentially at 180 degrees, only on the one direction. Whereas this has half its light in one direction and half its light in the other. So that is pertinent to the type of light that you're putting this in. For example, if you have a reflector and also a refracting lens in front of the bulb, then you would want this 360 degrees all around, because you want light to bounce off the reflector and you want it to be projected forward through the refractor lens. On the other hand, if it's a fitting that doesn't have a reflector and you're essentially, the light's only really being expected to go in the one direction, then you would want to use this configuration instead. So the other thing to pay attention to here is the 5-year Osram guarantee. So what I'm going to actually test in this review is, firstly, its current draw. They claim that it draws 1 watt, 12 volts, 1 watt. We will measure that with a voltmeter. And the other thing we will measure is the light color. And finally, we'll just have a look at the relative brightness compared to a 10 watt filament bulb. That's to say in the car, so that you can see for yourself what it looks like, how it compares. Okay, I will go ahead now and open this up and take it out of its package. Okay, and here is our bulb. Now, as I was saying, this has a diffuser lens around it, which makes it almost impossible to see inside. If you look closely, especially if you get a flashlight or something and shine it through, you can see what look like linear ribs running longitudinally from one end of the bulb to the other, and they look like little support. They're there for reasons of holding it together. And if we connect up this thing to a power supply, which I will do now, we can see, when we look at it carefully, that the way that it is generating this so-called all-around light is there are two chips in it, but they're not placed on opposite sides of a PCB which runs lengthwise along the middle of the bulb. Rather, they're placed at either end, and so each chip is firing toward the middle of the bulb. But obviously there's some kind of reflector or diffuser system in place there, which I can't really make out. And I'm not prepared to destroy this bulb in order to get a look inside. That's enough. We can tell how it works, and it seems to work well enough. I mean, you certainly do get 360 degrees of even light spread from that kind of setup. So, good. And the other thing I will do is show you the relative brightness. So this is the LED, and I will compare it for you to firstly the 10 watts filament bulb, which is what this would be replacing. There that is. To my eye, it looks much the same, so we're going to have to, apart from the color difference, obviously, the sort of perceptual brightness seems similar. Although the filament bulb is more intense because, of course, I'm just looking straight at the filament and not looking at it through a diffuser, so that may be an illusion. What I'll do is I'll take comparative photographs later of it installed in the car. I'll just make one more point while I'm on this topic, though. That was the 10 watt filament, and this is not a 10 watt filament. This is a 5 watt filament. And you should be able to see on this picture that that's half the brightness, obviously. The other thing it's worth pointing out briefly is the polarity does not matter. So it has some circuitry inside the bulb which is taking care of the problem. Usually with LEDs you put them in the wrong way around and they don't work, and you have to rotate them 180 degrees and then try again. But with these, it doesn't matter. Right, one last thing I want to do on the test bench here, and that is measure the current that the bulbs draw, and therefore the total power. So that's flickering between 70 and 80 milliamps, so let's call it 75 on average. And so that comes out as 0.9 of a watt, which is quite close really to the 1 watt that they claim. Previously, when I've tested other Osram bulbs where they also claim 1 watt, they're closer to 0.6 from memory. So that's quite good, 90% of claimed power. Right, the next thing I'm going to do is measure the color temperature of this bulb. Now they claim 4000 Kelvin, so we'll see what it actually is. The way I'm going to do that is light this piece of white card with just the bulb, and then take a photograph of the card with a half-decent DSLR camera. And then the resulting photograph, when I open it in Photoshop, which is what you see here, will allow me to measure the white balance using the camera raw processor. Now the way I do that is select the white balance tool and just increase the exposure a little bit, and then just randomly sample places on the photograph, and I'm measuring about 3800, 3750, 3850, 3800. I'm going to go with 3800 there as the measurement. Yeah, 3800. So that is that's 200 Kelvin or thereabouts less than what's claimed, which is quite significantly warmer than what they're claiming. Other Osram bulbs that I've tested before have come out closer to the 4000, or actually a little bit higher. So I guess you can't rely completely on brand consistency. But in general, that's okay, a 3800, especially for interior lights. We want them probably a little bit warmer than otherwise, and it's still a very neutral white. So in general, I'm happy with that. It's not too bad. Right, I'll go now and install this light in my car, and we'll have a look at how it actually performs in real life. Also compare it to the old incandescent 10-watt bulb. Now, I actually have two of these, and I want to use them in the courtesy light positions in my car. So as you can see from this front courtesy light design, it has a reflector at the top above the bulb and a sort of Fresnel style diffusing lens at the bottom. And so, yeah, we want the all-around light so as to best replicate what the incandescent filament bulb is doing. And there it is working. And by the way, this my car operates this sort of fade-in, fade-out thing when the courtesy light gets activated and deactivated. And you can see that that's still working here with the LED, so that's good. And the other thing that I noticed is that when the car's ignition is on, but the courtesy lights are not on, there is, with the LED, there is this very subtle, very dim glow, which is just there all the time. So the bulbs are very slightly powered on. There's obviously a little bit of residual current left in the circuit. So that's nothing to do with the bulb itself. It's obviously a function of the way the car's electronics are set up. And I actually don't mind it. It's kind of neat. It's not so bright that it's a distraction at night time or anything like that. And now we will get on to the comparison. Here on the left is the 10-watt incandescent filament bulb, and on the right is the Osram LED. And straight away you will see that this review is now going to take a slightly negative turn. So these photographs are taken with the camera in exactly the same position and with exactly the same exposure settings, and the only source of light in each shot is the light itself, the courtesy lamp, which you can see at the top. And the white balance is set the same in both photographs, so you can get a good comparison of color. That's the first thing to look at. So obviously the incandescent looks relatively yellow, and then the LED looks quite white. And this, I've adjusted these photographs to look to my eye in such a way that they best represent the real view that you would get if you were looking at it yourself. But the real problem is not with the color, it's with the relative brightness. As you can see, the Osram is quite significantly dimmer than the 10-watt incandescent bulb. Here's the full screen shot of the incandescent bulb and the Osram LED. So this isn't great because Osram claim that their bulb is three brightnesses, and if we assume that they mean, since we're replacing C5W, which would normally be a 5-watt filament, let's be generous to Osram here, then that would indicate that they're claiming that their LED bulb is 3 times the brightness of a 5-watt filament. That's to say something equivalent to a 15-watt incandescent filament bulb. And well, that's clearly not the case. And here's that both pictures on the screen at the same time, this time with histograms, which I captured from Photoshop. These are luminosity histograms, and if you don't know how they work, they're basically a map of the distribution of relative brightness in the picture, with dark bits, so to speak, on the left of the chart and bright bits on the right. And the easiest way to compare these is just to observe that the histogram for the Osram has more dark bits on the left than the incandescent version does. You can also look at the statistics of the distribution at the bottom underneath these charts. So the mean for the incandescent is 45, and the mean for the Osram is only 31. The median for the incandescent is 26, and the median for the Osram is 18. So that's not great, and yeah, I really have to give this thing a negative review now, because this is just way, way, way different to what Osram are actually claiming. I wouldn't go so far as to say the bulb is useless, because if you don't care about brightness, then this may still be useful. It may in fact be useful for applications such as the license plate example that I gave earlier, where you actually don't want the brightness. But yeah, I mean, since it's not what they're claiming, nothing even close, and since it's significantly dimmer than the original incandescent bulb in my application here for these courtesy lights, I think I'll have to take them out and I'll put the incandescents back in, because it's just not good enough. Right, that's it.